In this lesson, I'm going to demonstrate moving forward working with list comprehensions. Now, what is list comprehension? Essentially, it is just a more readable way of working with lists. The output is the same, just like when you work with existing lists, you get an output. List comprehension is just more easier, perhaps. So let's begin. I'm going to first create a quick list so I can demonstrate, so you can see actually what I mean by a list comprehension. So I'm going to quickly go ahead and create a list, call it nums, and I'm going to call it just some random numbers here. And then eventually, if I like to create an empty list and then append something to it, first typically I would write something like, let's say, my list here, just create an empty list and then do a for loop for n in nums, and do a my list, do an append for n. Then of course I need to print this out so you can see the output. Print the my list. If I run this, notice you get the same result. You get 1, 2, 3, 4, all the way up to 9, which is essentially the actual list. So you'd have to write this entire code if you need to. Use the append method, for instance, and you have to create an empty list. Now, list comprehension is easier. For instance, if I were to do something like my list equals, and here right within my list, instead of leaving it blank, I can say n and do a for loop within this right away. So n for n in nums, and then just simply print it out. So let's run it. And notice in this instance, you'll also get the exact same result. So no matter whether you use the first method or using the list comprehension, it's much easier to work with when you're working with list comprehensions. All right, great. Next, I'm going to demonstrate a very important concept of linking lists together, especially when you have various nodes. How do you link lists together? And this is important because when you're writing code, practically speaking, you would end up doing this. So let me go ahead and first show you our concept, so you can actually see what it is that we're about to do and what it is that we'll be working with, and our output as well. So here, for instance, let me first show you a little diagram so we know exactly the flowchart and some of the operations that we'll be working with. So let me bring this up quick. Here it is. So the various operations that we'll be looking at is the get size, find, add, and remove data within our list. Okay, and here's the concept. We'll have essentially 3 nodes. Here's our first node, which is also the root node, which has some data, and then this will link to the node in the middle, and then finally to the third node. So basically it's going to loop around and look for the 5. If it finds it, fine. If it doesn't, then it's going to go find the data in the next node, and then we'll do some add operation, and then of course remove as well once we're done with this. So just think of this as linking lists among nodes. All right, great. So let's go ahead and let me get rid of this for now, and let's start building our code. First, I'm going to define a class here. So I'm going to do class node, and then do an object, and then do my def function here, and do a self, maybe a d or n equals, I'm going to specify that to be none. All right, great. So what is self? Self will use the data method. This will equal d, and then the next node will hold the value of n. So here's my first definition for the node itself. Next, do another def, and this time I'm going to say get next self. Again, if it doesn't find it in the self, then we're going to go ahead and move to the next node, and it's going to return self dot next node. Great. Do another def, and if it finds it, I'm going to set it up. So set next, and this will be self and then n as well. And I'm going to do self dot next, specify the mode and the value of n. All right, do one more def here for the data. So I'm going to set the data also. And this will be self and then D. And do a self and data again. And this will equal D. All right, so far, you can see what we're doing here, right? So we simply created a class, initialized it, and we specified various methods for moving from one node to the other, okay? So if I bring this up again, this is exactly what we did so far. So we did the get next, set next, and then the set data. All right, let's move this, make sure we get our spelling correct. All right, next, do another class. And this one is going to link our list with our objects, okay? So we're going to do a linked list, for instance, and then the object itself, and then do definitions within this class as well. T, and this is going to be self r equals none. And then I'm going to do self.root equals r. And I'm going to do self.size equals 0. So this is basically our class linked list to our object. So see essentially what is going on here, okay? Let me bring this up one more time just so that I can clarify, okay? So each node is basically two parts. First is the data part, and then the next part links to node in the middle, or node 2. And it will always point to the next node. And the very first node is obviously the root node and keeps a pointer to the next node, okay? And the last node, obviously, there is no next pointer, so it will be a null or none in Python. And that's when we define the value of none within our code. So the find data is essentially going to find and compare the values of, let's say we're trying to find 17, and it's going to find it. If not, it's going to add and go to the end of the list. And let's say, for example, if we need to add 10 to our list, we will add a new node, and eventually we'll change our root pointer that changes to and points to that node that contains the 10. But before we actually go about pointing the data or the node that contains the number 5, for instance, and point it to the node that contains 10, we need to find the data first. So we need to code it up so that it goes ahead and finds it. And essentially, the node class is the building block for the node. And a couple of arguments that we used is the D and then the N for none. So I wanted to make sure that we're clear so far. So here in the linked list, we need two variables. One is the root, which points to the R, and the other one points to the 0. Okay, so good. Let's go ahead. Continue. Let's do a def, and then do a get size, and then do our self. And this is going to return the self size. And then we need to also make sure that we do a def add for the self and D. And then we do our new node. Okay, this is what I mentioned earlier, where we create a new node and let's say put in value of 10 or any other value, and then we have to point the original root node to the new node. Okay, so this is going to be a new node. Scroll down so you can actually see, and this is going to be node, and then specify D and do a self root. Do a self root, and this equals new node. Well, let's do a self dot size plus equals 1. And of course, I need to make sure I spell it correctly and make sure I get my indentation correct. And the reason why it's not doing the n equals n plus 1, and this is because I need to make sure that I have my semicolon, and now our code seems correct. All right, next I'm going to do a definition for the remove part. So I'm going to say remove self and D, and then I'm going to say this node, for instance, equals the self root. and then the previous one, so I'm going to say previous node equals none. So once I'm done with this, next I'm going to do a while loop, okay, and then I'm going to nest multiple if statements so that it finds the data, and if not, it goes to the next node. Okay, so let's do a while. So I'm going to do, let's say, while this node, and then do an if this node dot get data equals d. Do another if previous node or prev node, that's the naming convention I used, prev node dot set next, and I'm going to say this node dot get next and close it. Okay, and then do an else. Then I'm going to tell Python to go ahead and do a prev node, and this at this point should equal this node, and then continue on to say this node, and this time it will equal the get next, right? So previous node equals this node, and then this node is going to go ahead and move to the next node. So I'm going to say this node dot get next, and instead of comma, it's this node dot get next, and then of course I need to have my return as false, and of course this is only if the data is not found, right? So if it does not find any data, it's going to return a false value. I just put a comment in here. All right, let's do our def for the find, self and d, and then do this node equals self root, put a dot, and then do another while here for this. So while this node, so while this node equals self root, well, not at this point, it's not going to equal self node, it's just going to loop. So while this node, and I'm going to pass this argument, instead of pass I'm going to say if this node dot get data equals d, then return me the value for d. Okay, so return the value for d. All right, good. Otherwise, else this node should equal this node and get to the next one. So this node dot get next, and then eventually do a return to none. Perfect. All right, and the last piece, once we've specified all these nodes, now at this point, in order to use our list, we can in fact come up with a new list and then add some operations to it. So for instance, I can do something like my list, make some spaces here so you can see. All right, so I can do my list equals, let's say, linked list, and then maybe I want to do some operations such as add a number to a node, not just one, maybe a couple of them. Okay, so I can do something like my list dot add, and maybe I want to add 5, and then do another one, my list dot add. This time I want to add 8, and then do another add quickly, and this time I'm going to add 12, for example. And I can also do an operation such as remove, for instance. So I can do my list dot remove, and maybe I want to remove the 8. And finally, let's do a print so we can actually see our results. So I can do print my list dot remove, and let's say 12, and then also do a print for my list and find. Okay, let's do the find operation here. And what am I looking for? Let's say I'm going to find 5. Okay, great. Let's save our code and let's run it and see what happens, whether we get some syntax errors or not. Let's scroll up just to verify quickly, just to make sure we have our semicolons and our indentation correct. All right, so far looks good. Let me scroll down. All right, Perfect. Let's do Control B for Bravo and run. And let's go to line 34. All right, what do we do in line 34? We said while this node, and yes, the error of course is that I need to do the underscore to make sure we have our names correct. Let's run it again. Okay, here's the reason why. And the reason why is because we did the if and nested another if, but we only did one else, okay? So, and that's probably why it's not callable. So let's fix this. So let's take a look. So while this node, if this node is going to get data, which is D, and then we did the if, so if previous node is set next, and this node dot get next, which is fine, else, all right, else, not the previous node. So we need to make sure that our else is in fact self root equals this node, and then get next. This is what we were missing, okay? So self root equals get this root, and then we need to define the self size, and this is going to be minus equals 1, and of course return the value if it's true. So return true, and this is because it's going to remove the data, okay? So let's say data removed, so we know to put our comments. All right, then once that's done, scroll down here. So else self root this node dot get next, which is fine, and then return the value to true and remove this data. Once this data is removed, then do our else again, okay? There we go. Now we're getting it. All right, so else previous node equals this node, and this node equals, then get to the next node. Perfect, and then return the value false if it does not find the data, okay? So the reason why we missed this, that was the reason why we got this none type object is not callable, because it's trying to find this object and it cannot, because we didn't specify what else to do once you move to the next node. All right, so let's test this out one more time, because for now we have our if corrected, and then of course we have our else as well. All right, great. So once the loop is corrected, let's save this, run this, and perfect. Now we get our value to true. So in this instance, it successfully removed the 12, I believe. Let's scroll down to check our code. Yes, so it removed the 12 and printed the result, which is true. And then it also found the list with 5, okay, and it provided this value as an output. So this is a good way to link nodes together and working with linked lists. So practice working with this. You may have to do it a couple of times to get the gist of the linked list, but it's an important concept, especially working practically with Python. And let's move to our next lesson.